Is this concept okay? Gross tangent is simply this ratio sigma by rather epsilon naught. Finally, EM wave propagation in good. So what is a good conductor? Good conductors are like metals which can very conduct good electrons with a very low resistance. So what do we expect in good conductors? What do we expect in good conductors? Anybody? What do we expect in a good conductor?
The sigma value will be high.
Exactly, sigma value would be high. So this is similar to what happened in the previous case. Sorry, it is exactly the opposite of what happened in the previous case. In the previous case, this term used to dominate over this term. Now it is the opposite. Now this term dominates over this term. This term is not zero, but this term is much higher. Or JC is much greater than J. Now you tell me the expressions for alpha and beta. What was alpha? I told you required in B. Alpha was who wrote it down? I have it.
And omega square
Omega
mu
square.
0 epsilon r
Omega square mu 0 epsilon r then
by 2.
by 2. Then there will be another square root, right? Right? 1 plus what?
Sigma square by omega square into epsilon 0 square into epsilon r square.
Epsilon r square. Okay. And beta will be exactly the same except this minus 1 will become plus. Now see, if sigma is much greater than this term, then this term is much greater than 1. Agreed? Agreed? If sigma is much greater than omega naught epsilon r, then this should be much greater than 1. Agree or not?
Yes.
Right? So we can simplify alpha and beta as this way. Alpha almost equal to omega naught mu naught epsilon r by 2. Sigma omega, sorry, not omega. Sigma omega naught, sorry, epsilon r minus 1. Beta omega square mu naught epsilon r by 2. Sigma omega, right? We can write this. We can write this. Is it okay to write this? Is it okay? Are you there?
Yes, sir.
Right?
Yes.
Once again, this term is much greater than 1. Same logic. Sigma is much larger, so this term is much greater than 1. So both alpha and beta, this becomes omega square mu naught epsilon r by 2 sigma. Can we write this? Because sigma is much greater than omega epsilon. Can we write this? Okay. So see, many terms gets cancelled out. This gets cancelled out and 1 omega gets cancelled out. So alpha equal to beta, that is almost equal to omega mu naught sigma by 2. What a very good dielectric conductor. Okay. Is it okay?
Yes,
Yes, sir.
sir.
Okay. What is omega? 2 pi f. So this can also be written as pi f mu naught sigma. Right? Right. And our final expression will be the same. E equal to E naught cos of omega t minus beta z to the power of minus x alpha x j. Right? But see here, sigma is a very large number. For example, for copper, sigma is 5.8 into the power 7. Check the value. I think it is like this. Siemens per meter. Okay, something like this. And if f is equal to 1 gigahertz, what will be alpha? Just put the value to tell you. Use this expression alpha equal to pi f mu naught. Again, what is the value of alpha coming? If you use this values, let me check it once. Use this values. This probably can give us yeah, 5.8 into the 7 series. Right. What is the value of alpha coming at 1 gigahertz? Just put the values again for copper. Anybody? Getting this answer?
Yes.
So this is how much? 4.78 into the power of 5 meters. Meters per meter. So this value is alpha 4.78 10 to the power of 5 meters per meter. Are you getting this value? Now, what happens at x equal to 1 by alpha? For the value of x that is equal to 1 by alpha, what happens? That E becomes E dot by small e. From the formula, if x equal to 1 by alpha, then e to the power of minus alpha x will be e to the power of minus 1. Oh, you told the answer. Thank you. I didn't know. Yes, yes, very good. So at x equal to 1 by alpha, this will be the result. E will be E naught by E, right? This distance of x equal to 1 by alpha is called skin depth. What is skin depth? The distance inside the conductor where the electric field falls into a value of 1 by E times that the value of its surface. Understand? If I
Sir, please repeat.
yes, I will. If I have a conductor, okay, and there is some electric field is flowing, it will accumulate very fast, right? And what is skin depth? If the value of electric field at the surface of the conductor is E naught, then at what distance it will become E naught by small e, this one. That distance is skin depth. You understand what is skin depth? When an electric field enters a conductor, it will attenuate very, very fast. Remember electric field. The electric field inside a conductor is 0. Remember that? So it will attenuate very, very fast. And what is the skin depth? At skin depth, the electric field is 1 by E times the surface. Now, can you calculate the skin depth here? Skin depth is simply 1 by alpha or 1 by pi f mu sigma. So, if alpha equal to this, what is 1 by alpha? Just equal to 1, 2, 3.
2.1 into 10 to the power minus 6.
Yes, very good. 2.1 into minus 6. So, this is equal to 2.1 into the minus 6 meters or 2.1 micrometers, right? So, you can imagine within a distance of 2.1 micrometer inside the conductor, the electric field value will become 1 by E times of the value surface, right? And a distance of square of that, it will become even more 1 by E. So, on a very narrow short depth, the electric field just vanishes. It becomes very zero, very zero, right? It just
Sir,
attenuates very
equal
fast.
to sir equal to E naught by E or equal to E by E.
Depends on if E naught is the value of the field on the surface, then it will be 1 by E. If the electric field at the
Okay.
surface is 1 volts per meter, then at skin depth it will become 1 by E volts per meter. Okay? And at a distance of what will be at the distance of twice the skin depth, what will be the value of the electric field? twice the skin depth. At skin
Sir,
depth,
E naught by E square.
E naught by E square, right? So it falls exponentially, right? You can see how fast it falls inside the meter. Now let us do some funny things. If do you know something called spin effect? Have you studied spin effect of AC current? Spin effect. It is something called spin effect. Spin effect means that if no matter how faster, the higher the frequency, the more current it flows along the surface of the conductor. Inside the conductor, the current flows goes down. This is the same thing. Because this spin depth, if F is 0, then spin depth is infinite. If F is 0, then delta is infinite. So the current can flow throughout the surface of the conductor. However, as F increases, the spin depth becomes smaller and smaller, and the current is concentrated on the outer half of the conductor. Understand?
Sir, what is after S equal to?
If F equal to some delta, then delta is equal to infinite. For DC, spin depth will be infinite. Put the formula. What does that mean? That the current flows throughout the surface of the conductor. However, as we go on increasing the frequency, the current flow is concentrated mostly towards the outer half of the conductor, outer parts of the conductor, not towards the inside. This is due to the spin effect. And this phenomenon is called spin effect. Okay. Is it okay? Let us continue. What will be H? H we found out to be omega mu naught by alpha plus g beta. This was my, sorry, this was my eta. Okay. So my eta. But we have alpha equal to beta, that is equal to pi f mu sigma. So this is omega mu naught 1 plus j pi f mu naught sigma. So this will be 1 minus j omega mu naught by 2 pi f mu sigma. That is equal to which one is cancelled out. 1 minus j equal to mu naught by 2 pi f mu naught sigma. 2 gets cancelled. 1 minus j pi f mu. This is my beta for good questions. Is it okay? Just put the values, you will get this answer. Anything else? Can we do some problems? Just see some problems.
Sir, what is the relation between F and delta?
Okay, right. We have a material for which epsilon r is 3.2 and sigma is 1.5 to the power minus 4 Siemens per meter. So this is a good conductor or good dielectric? This is a good conductor or good dielectric? Which one is this?
Sir, please repeat the question.
I have a material for which C is epsilon r and sigma is here in the volume. So the material is a good conductor or good dielectric? What do you think? Which one is it? The value is C and here is 10 to the power minus 4.
A good conductor.
Why?
The sigma value is very high.
It will minus 4.
Oh, minus 4.
Yes, it will go minus
I
4.
thought it was plus.
Then it's a good dielectric because it's very less, very low. So one, we need to find out at 3 megahertz, find A loss tangent, B alpha, C beta, D mu. How to find? What is loss tangent? Loss tangent is tan delta, that is sigma by this one. So we can put the values. Sigma was 1.4 minus 4. It was 3 megahertz and epsilon r. Epsilon is equal to epsilon naught. Epsilon equal to epsilon naught is 8.85 into minus 12 times epsilon r. Epsilon r is 3.3. Okay. So loss tangent, that is equal to sigma slash 3.5 is epsilon, that is equal to 0.28. That is equal to 0.28. Getting this answer? Oh, that is bad. Okay, the problem is already given on the board, so just find it out. Then you find alpha and beta from the formula. You put those four values and get the answer. And finally, when you get alpha and beta, you find. So what is alpha? Alpha is from SQRT. So you just put the formulas and you get the values. Okay. Any questions you get in class before we begin? I think a class at from 4. So any questions?